This will all be stuff we've done in grade 11 and some stuff in grade 10. We're going to go through each of the solutions just to help us get back in the swing of things with getting familiar with our special triangles, our sines, our cosines, and our tans. We're going to start with question 1. So we've got the terminal arm of some angle, so I'm going to call that angle theta because they don't say what it is, has an end-point of -1, -1. We're going to figure out the measure of the angle. Okay, so I'm going to highlight a few things there as I read through it again. So we're going to talk about a terminal arm. Okay, so I think that's where an angle stops or terminates. And it has some endpoint at -1, -1. We want to find the measure of the angle. All right. So maybe we'll try to draw a picture to start with. All right, so I'll start with a set of axes: 0, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. And I know there's some angle that I can draw so that it ends at the point, let's call this -1 for x and -1 for y. So it's going to end here at the point -1, -1. Okay. The question is, well, okay, what angle is this angle theta? How big is it? So the way I would go about that is I would start by making a reference triangle, a right angle triangle. I would start labeling it up. So we've got a -1 along here and a -1 along here, and that looks like our special triangle. That's congruent to our 1, 1, √2 triangle, which has angles of 45 degrees and 45 degrees. Alright, so that means that this hypotenuse is √2. And it also means that my reference angle here is 45 degrees. Okay, so that's pretty key. Now that I know this is a 45-degree angle, and I know that it's 180 degrees for this part of the angle, plus another 45. So theta is equal to the 180 degrees plus the 45 degrees. So theta is 225 degrees. Okay. So we'll move on for question 2. Okay, question 2 looks like it's worded very similarly. So I'm going to spend a little bit less time decoding the wording here. I'm just going to start drawing the diagram. So I know we're going to have an x value for this point in the fourth quadrant, which is x is √3 and y is -1. So it looks like we'll have some value, say, out here. And that'll be the point √3, -1. √3 is a little bit bigger than 1, and so I've drawn it accordingly. Maybe I'll exaggerate it a little bit, but it's roughly to scale. Alright, and I know that this side length is √3, and this side length is √1. And that tells me that this is congruent to our special triangle. 1, √3, and 2, special triangle. And that angles we had memorized, there's 30 degrees over here. The smallest angle is opposite the smallest side. And 60 degrees is over here. Okay. So that means this hypotenuse must be 2. And I know this angle here is 30 degrees. Okay, so theta, our angle, is equal to, well, it looks like we're a little bit shy of going all the way around the triangle. So it looks like a little bit shy of our 360 degrees here. So I might say it's 360 degrees, take away that little bit of angle, minus 30 degrees. So theta is 330. Nope, not 333 degrees. theta is 330 degrees. Okay. So next, we've got this ratio. We know that some angle, if you look at the cosine of it, meaning the adjacent over the hypotenuse of it, it's 28 over 53. And so wait, let's take a second to decode that. Okay, what does that mean? So if we've got some statement like cosine of theta is 28 over 53, that means we have an adjacent side to our angle, that's 28, and a hypotenuse that is 53. Okay, so we might start by trying to say, okay, well, which quadrant are we in? All right, and cosine is a positive angle. So if I think cast, or all students take calculus, or Allie and Scott are table companions, we know that our cosine could be positive here, and our cosine could be positive in this quadrant. So we could be in either of these two quadrants, but in these two quadrants, cosine is negative, so these guys are out. And it doesn't really show up in the video, so I'll draw that in a little bit more. Okay, so we're either in this quadrant or in this quadrant. So I'm going to try to draw a triangle. It has an adjacent of 28 and a hypotenuse of 53 in one of these two. Now I'm going to go back to the question, see if we're told any more information. And we are. We're also told that our theta, our angle, is somewhere between 270 degrees and 360 degrees. And just to remind you, that means that we are in our fourth quadrant. Okay. How's the focus here? Can we focus any better? Not really, eh? Okay, well, I'll try and write a little bigger then. So, okay, I know we're in quadrant 4, so I'm going to draw this triangle in quadrant 4. So I've got some angle, we'll call theta, and it terminates here. And what we know is that there's some reference angle, and the adjacent is 28, and the hypotenuse is 53. Okay. So I might say, okay, well, how big is this angle? What can I do to find the size of that angle? Well, hang on, wait a second. What am I asked here? Oh, we're asked to find the ratios for sine theta and tan theta. I see. Okay, that makes more sense. Okay, so for sine theta, sine in my SOHCAHTOA statement says we're looking for an opposite side divided by a hypotenuse. So to write sine theta is going to be opposite divided by hypotenuse. But we don't have the opposite. So before we can find sine theta, I can put my hypotenuse of 53 in. But I don't know the opposite, so I have to find it. So we'll do that over here. So it says 28 squared plus, we'll call that x squared, is 53 squared. And we'll just find x. So I'll say x squared is equal to 53 squared, take away 28 squared, which is kind of bad algebra habits, actually. I should probably simplify before I do anything else. So actually I'm going to do that now. 53 squared, take away 28 squared, it's 2025. X squared is 2025. Okay, so what could x be? I'll square root both sides. And, of course, plus or minus on both sides. So then I get x is equal to plus or minus the square root of 2025. I think the square root of 2025, do I know that? You know what, I might not know that. 45? I don't know. What is the square root of 2025? It's 45, okay. So that means x could be positive or negative 45. In this case, it'll be a negative value. So we're going to put negative 45. It's negative because it's going below the x-axis. And then, of course, this point here, that coordinate would be the point 28, negative 45. All right, so that means our hypotenuse is 53, but our opposite is negative 45. Okay. And now it's pretty trivial to write the tan theta 2. Tan is opposite over adjacent theta, and it's going to be equal to negative 45 over 28. Done. All right. Question 4 is pretty similar in nature. It says, all right, we've got some ratio, tan theta equals 3/2, and tan is part of our TOA part of our acronym, which means opposite over adjacent. So that means this is an opposite, and that's an adjacent side. Okay. And we're also told the quadrant that we're in. So if we were to draw a set of axes and label up all our angles, we find that this lands in between 180 and 270 somewhere. So we're going to draw an angle theta. Opposite's 3, adjacent's 2. So I'm going to draw a little bit bigger. Something like that. And I know it has an opposite of 3 over 2. Now, that's actually impossible, right? In this quadrant to have an adjacent or an opposite that are positive. However, this could also be equal to 3 over 2 is also equal to negative 3 over negative 2. So I could also say the opposite is negative 3, which fits in this model, and the adjacent is negative 2. And we'll probably need to find the hypotenuse. So to find the hypotenuse, I'll take that negative 2 and square it, add it to negative 3 and square it, and get the hypotenuse, which is, we'll call it x squared. And that'll give us 4 plus 9 is equal to x squared, or 13 is equal to x squared. And then I will square root both sides. All right. Now, hypotenuses are always positive. Oh. That's a big one. Okay. So that means we're going to take the positive value there and put it up here, root 13. Okay. So then we're asked to find, wait, hang on, what are we asked to find here? We're asked to find sine theta and cosine theta. Okay, so sine theta should be equal to the opposite divided by the hypotenuse. So, yep. So ka toa. Okay, so sine is the opposite, which is negative 3. Over the hypotenuse is root 13. So it'll be negative 3 over root 13. And cosine theta is equal to the adjacent, negative 2, over root 13. So question 5 is going to ask us to solve for each of these values, considering all possible angles of theta. And one thing we did to edit this question is we unrationalized the denominator and wrote it as 1 over root 2 to help us attack this question. All right. So let's read that more carefully here. 5a. All right. So we're asked to determine theta. What angle is such that, oh wait, sorry, I forgot, we made it negative root 1 over root 2. Okay. What angle is such that when you take the sine of that angle, it gives you negative a half? It turns out there's actually many answers to that question. However, only some of those angles are between 0 degrees and 360 degrees, and that's why we have this domain restriction here. We're only looking at angles between 0 and 360. Okay, and so if we have angles between 0 and 360, which ones give us positive sine values? And that's going to be in our all quadrant, quadrant 1, and our sine quadrant, which is quadrant 2. Okay. So, oh my gosh, why would I label at 90? What am I thinking? So we have 0 degrees over here, we have 90 degrees up here, 180 degrees down here, 270, and 360 degrees. Okay. We have these. It's possible for this triangle, or sorry, this angle theta to be in the first quadrant. Pardon me. Oh, I actually didn't notice sine is negative. So actually we don't want it to be in the first or the second quadrant. We want to be in the third or the fourth quadrant. These are our T and C of our all students take calculus memory device. This is where sine is negative down here and down here, because sine is positive in these two quadrants. So I could have an angle theta that terminates in quadrant 3. I'll call that theta 1. Or I could have an angle that terminates in quadrant 2. And I'll call that theta 2. And I'll draw triangles in both quadrants that fit this possible condition. Okay. And what are we told here? We're told that the sine ratio is -1 over 2, meaning the opposite over the hypotenuse is a -1 over 2. Now we know hypotenuses are always positive, so what that really means is we have a -1 opposite and a hypotenuse of 2. So that means we'll have a -1 opposite side and a hypotenuse of 2 in both conditions. And this is similar to a particular special triangle we've seen before. So we know the other dimensions of this triangle as well. And we also know that this reference angle is 30 degrees. Okay, and if we know that it's 30 degrees, we can probably do some reasoning here. We know that theta 1 is equal to the 180 degrees plus 30 more. That's equal to 210 degrees. And we know theta 2, we can see it goes almost all the way to 360 degrees. But we're 30 degrees shy. That's 330 degrees. All right, and that's how we approach these questions. All right. So we'll move on to question B. Question B is very similar. It says that cosine of theta is equal to -1 over root 2. All right, so let's say, what quadrants could we be in here? We could be in quadrant, cosine is negative, so this is all are positive. Only sine is positive, which means quadrant 1 is fair game. Only tan is positive down here, which means quadrant 3 is fair game. Cosine is positive here, so that means this one's out. So these guys are out. So we could have an angle that maybe terminates in quadrant 3. Call that angle 1, or theta 1. And we have some angle that could terminate in quadrant 3. We'll call that theta 2. Okay. And so we'll draw some triangle here. And we know that we have some cosine chi, which means we have the adjacent over our hypotenuse here. Which means our adjacent is equal to -1, but our hypotenuse will be equal to √2. So we have a -1 adjacent, and our hypotenuse is √2. Okay. So that's looking a lot like a special triangle we know. So we probably can see the reference angle is actually 45 degrees. And so that tells us that θ1 looks like it almost gets to 180 degrees. But it doesn't quite get there. So it'll be 180 degrees minus that 45 degree reference angle, which actually leaves us with 135 degrees. θ2 is equal to, looks like 180 degrees plus 45 degrees, which is 225 degrees. Those are our two answers for question B. Question 5C. We're told that tan theta is equal to -√3. Now, what's important to remember is that, okay, that means opposite over adjacent, right? But how can √3 be an opposite over an adjacent? Well, only if our opposite or adjacent, pardon me, if our √3 is over 1, because √3 is the same thing as √3 over 1, and -√3 is -√3 over 1. So I can think of that as being -√3 over +1, or I can think of it as being √3 over -1. So that means we could have an opposite equal to -√3 and an adjacent equal to 1, or we could have an opposite equal to √3 and an adjacent equal to -1. Okay. So, what are we doing here? We got a -tan ratio. Okay, so what quadrants could we be in? We have 0 degrees here, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. And we have a -tan ratio. So we can't be in this quadrant because this is where all are positive. So we're out here. We can be in this quadrant, though, because sine is positive, but all the rest are negative. So tan's fair game here. In this one, we have tan being positive, so that's out. In this one, we have cosine being positive, implying all the rest are negative. So we're good here. So that tells us that our angle could actually terminate in two different locales. It could terminate in this quadrant, or it could terminate in this quadrant. And we'll call these θ1 and θ2. All right. So I can draw triangles, reference angle triangles in here, that are going to be to scale, or pardon me, not to scale actually. So we're going to have some opposite of -√3, which actually corresponds to this diagram here. You have an opposite of -√3, but an adjacent of 1. Or, in this quadrant, we have an opposite of √3 and an adjacent of -1, which is interesting. All right, and you're probably seeing this looks like a special triangle we've seen before, and it does. Okay, and we know that that means that this angle is 60 degrees, our reference angle. Okay, so that tells us that θ1 is equal to 180 degrees minus 60 degrees, which is 120 degrees. And θ2 is 360 degrees, but it didn't quite get there. We're going to take away that 60 degrees, and it's going to take us most of the way there. That'll be 300 degrees. All right. So, for question 6, looks looks like we've got a bunch of trig ratios, and we're just going to need to find the exact value for each of them. Okay. So let's start with cosine of 150 degrees. So the first thing I would do is I would draw 150 degrees. And this is not to scale, and that means I know I have 30 degrees left. So I can draw in a reference angle triangle here. And that's going to be my 2, 1, root 3 triangle. And so that'll tell me my cosine of 150 is going to be my adjacent over my hypotenuse. Negative root 3 over 2, which equals to just negative root 3 halves. All right, simple enough. So question B gives us tan of 315. Okay, so I'll draw 315. It's going to be in this quadrant in between 270 and 360. And after 270, that takes us with 45 degrees, meaning there's actually 45 degrees left between 315 and 360. So it's 45 degrees here. So I can draw a reference angle triangle here as well. And a 45 triangle means we have a side of 1 and a root 2 hypotenuse, and then we'll have a negative 1 over there. So we want tan of this value. We can say tan of 315 is equal to negative 1 over 1, which is just equal to negative 1. All right. All right, so for question 6C, we're given the value sine of 210. Okay, so I'm going to start by sketching out 210 degrees. That'll be in between 180 degrees and 270 degrees. And 180 plus a little bit more to get to 210, that's going to be 30 degrees. And I know that if it's 30 degrees, I can draw a reference angle triangle, because 30 degrees is in one of our reference triangles. I can put this to scale as negative 1, negative root 3, and a value of 2. And if we're looking for the sine of that ratio, that's going to give us sine of 210, which is the opposite over the hypotenuse, which is negative 1 over 2. Cosine of 330 degrees is the next one. All right, so I'll draw 330. It's going to be in the third quadrant here, and it's going to leave us only with 30 degrees left before getting to 360 degrees. Okay, so that means it's 30. Oh, it looks like we're going to have the same triangle we had before. So that means we have a root 3 here, and a 2 and a negative 1 in our right angle triangle. And so that should help me find the cosine of this angle. Cosine is adjacent over hypotenuse, so cosine 330 is equal to root 3 over 2. All right, now we've got this question E here, which is tan of 120 degrees. Okay, so I'll draw 120 degrees. We've got 120, it terminates in the quadrant between 90 degrees and 180 degrees. And I think we'll leave about 60 degrees here before we get to 180, 60 degrees. So this is not to scale, so our reference triangle is going to have 60 degrees here and 30 here. So that means we'll have a 30, 60, 90 triangle. So 2, negative 1, and the opposite will be root 3. So tan of 120 degrees is going to be our opposite divided by our hypotenuse, which is going to be root 3 over negative 1, which simplifies to negative root 3. Okay. So lastly, we have a sine of 135 degrees. Okay, so to find sine of 135 degrees, I'm going to draw 35 135 degrees, which is in between 90 and 180. It's actually exactly halfway between. And that leaves an extra 45 degrees before we got to 180. So it's going to look something like this. Oh, and a 45-degree angle, which means we have 45. Oh, we know the ratios for that triangle. So that means it's 1, -1, and root 2. If we're looking for the sine of that ratio, that'll just be sine of 135 degrees is equal to just the opposite, which is 1, over the hypotenuse, which is root 2. Okay, so let me know if you guys have any questions about